Algebra 1, Lesson 1.5, Solving Inequalities in One Variable. Your objective, write this down in your notes. Students will be able to solve and graph inequalities. And over to my right, I have solving inequality. It's kind of what your solution will look like. It's a very simplified example. Okay, let's get started. All right, real quick, I said the word inequality. How is an inequality different than an equation? Well, let's take a very simple equation. X equals 2. That is going to give me one solution. There's only one possible solution that makes plugging in this value for x true. Observe, 2 equals 2. That's correct. 3 does not equal 2. 4 does not equal 2, and neither does negative 2. Okay? Only one solution with an equation, or sometimes no solutions, or infinitely many solutions with no restriction. But let's look at x is greater than or equal to 2. That's going to give me, let's do this one in blue. That's going to give me a dot here and all sorts of possible values. So is it true that 2 is greater than or equal to 2? Yes, 2 is also equal to. What about 3? Is that greater than or equal to 2? Also true. So that's right here. That falls in our range. What about 10? Is that greater than or equal to 2? Yes, 10 is greater than or equal to 2. What about negative 4? Is that greater than or equal to 2? We're down here. No. So an inequality gives us a range of possible solutions. And this range does go on forever. Sometimes it may not, but it's a range of possible solutions. It can also have an instance where there is no solution, and we'll see that shortly. All right, same rules apply with a couple exceptions here. We have a left side and a right side. First thing I'm going to do is distribute. Negative 6x minus 6 is less than 18. I'm going to add 6 to both sides to remove it. So negative 6 plus 6 is 0. Negative 6 less than 24. Divide both sides by negative 6. That gives me x is less than negative 4. Start here, open circle, because it's not less than or equal to, which means negative 4 cannot satisfy. Let's test it. If I plug in, looks like negative 5 should be a solution. So let's do 2 times negative 5 plus 2 less than 18. Negative 3 times negative 10 plus 2 less than 18. Negative 3 times negative 8 less than 18. Negative 3 times negative 8 is 24. Uh-oh. Is that less than 18? No, it isn't. Something strange happened, and I did this on purpose. Back here at this step, when you divide or multiply both sides by a negative number, the inequality switches directions. So this is no longer the answer. It's actually x is greater than negative 4. Okay, so I'm going to erase this. Let's use blue. We have negative 4, and we go greater than. And if we test it, let's plug in 0. Okay, it's an easy number. Let's plug in a 0. Negative 3 times 2 times 0 plus 2 less than 18. We're using the original inequality. Negative 3 times 2, is that less than 18? Negative 3 times 2 is negative 6. Is negative 6 less than 18? Yes. So we know that switching the inequality symbol is the right thing to do. If we don't switch it when we divide by a negative or multiply by a negative, we get weird results. Something that says 24 is bigger than 18, which we know is not true. I know you can tell I'm still at soccer practice. All right, so we got a left and a right side. First, I distribute. 2 times 4 is 8. 2 times negative 2x is negative 4x, and that's greater than 4. Subtract 8 from both sides. Negative 4x is greater than negative 4, right? Because I'm adding or subtracting. I don't need to change this symbol. But now I'm going to divide by negative 4. So I'm dividing by a negative number. That means this guy is now facing the other way. So I get x is less than 1. So I have an open circle, and I go back like this. I can check it. Let's choose 0. 2 times 4 minus 2 times 0 greater than 4. That's really just 2 times 4. Is that greater than 4? Yeah, it's 8. Sorry, it's greater than 4. We're good. Okay. Example 3. Make sure you're writing these down in your notes. I want to see all these examples when I do a binder check. I don't have to distribute. I'm going to try and keep it positive, so I'm going to subtract 2x. I'm going to move the x's onto the right side, okay? So I get negative 5 is less than 3x minus 22. I'm going to add 22 to both sides, and I'm going to get, what is that, 17 is less than 3x. Divide both sides by positive 3, so that means this guy stays the same. It's a less than symbol, which means 17 thirds is less than x, or x is greater than 17 thirds. This might help to write as a mixed number, so it's going to be 5 and 2/3 is less than x. So I'm right about here, and x goes that way. That means that this is the smallest value, so all my solutions are going to be up here. Okay, goes on forever. We're not going to plug it in. You're just going to have to trust me. All right, same thing. I got a left side. I got a right side. Left side I have to distribute, so let's do that first. Negative 2 times 4x is negative 8x. Negative 2 times negative 2 is positive 4. I think you can probably see a problem here. So I'm going to add 8x to both sides. Yeah, that's not great. So I got 4 is less than 4. Is this true? Is 4 less than 4? No, 4 is 4. If I had an equals to, or that little bar, which means 4 is less than or equal to, we would be good, but we're not. So this is no good. This is a false statement. So that means no solution. There exists no number in the real number line that I can plug into here and get a true statement. These are all examples from the book, but not the book examples. It just asks to solve some of these parts. So I have a left side and a right side. On the right, I got to distribute. So I rewrite my entire equation on the left, and then my expression on the left, and then I'm going to distribute on the right. Uh-oh, we have another problem here, don't we? We'll see. I'm going to add 6x to both sides, and I'm done. So I got negative 5 is less than negative 3. Is this true? Is negative 5 a smaller number? Well, let's look. Here's negative 5. Here's negative 3. That works. That's true. So that means it doesn't matter what number I put in into this equation here, I'm going to get a true statement down here. So I'm going to say infinitely many solutions. Wow, you're being really loud. So infinitely many solutions, so we're good. Okay, ridiculous teenagers are arguing in front of a vehicle while I do this. Recap! So we treat inequalities like equations when we're trying to solve them, okay? But there is one thing to remember. When you multiply or divide by a negative, change the direction of the inequality symbol. Okay, write this down in your notes. This is important to remember. Okay, you change the direction of the inequality symbol when you multiply or divide by a negative number. Okay, and when you graph the solution, you're going to, for greater than, x is greater than 3, it's an open dot and an arrow to the right. If x is less than or equal to 0, it's going to be a closed circle at 0 because I include the point 0. And if x is smaller than that, then it's to the left. Okay. Your assignment for this lesson is going to be on page 34 and 35. You're going to do number 12, 15 through 43, the odds, and then you're going to take a crack at 50. There's a couple letters here, like SD and ATD. If you have questions about those, come ask me. If you have any other questions about the material and you know how to get a hold of me, take care.